Button accepted.
Welcome everybody to my talk about functional programming in Kotlin, where we will be exploring the Arrow library. First, a little bit about myself. My name is Ties van der Ven. I'm from the Netherlands, and I work for a company called J-Driven. And I'm quite proud to call myself a software engineer, because I'm really passionate about the engineering aspect of software engineering. And with engineering aspects, I mean the software fundamentals, the higher-level abstractions, the higher-level concepts, and just the general problem-solving aspect of it. And because I'm very passionate about engineering, I love to talk about it. So you may think I came all the way from the Netherlands so you can learn something about functional programming in Kotlin. In practice, I just get to talk about my favorite subject for 15 minutes, and it's kind of rude to interrupt. On that note, my friends and family would like to thank you for finally getting a break from all that. But I wasn't always an engineer. In the beginning of my career, I worked on this big monolithic application. And with big monolithic application, I mean millions of lines of code. And with millions of lines of code comes a lot of complexity. And with a lot of complexity comes a lot of bugs. So most of the time, I was actually fixing and introducing new bugs to the application. And if you start fixing bugs for about 5 years, a few things start to happen. First of all, you start seeing certain patterns in that, hey, these bugs basically have the same root cause. And secondly, slowly a lifelong quest starts to emerge where you try to prevent these bugs from happening. Because if they get prevented, then I don't have to fix them. And in this quest to find ways to prevent these bugs from happening, that's where I encountered functional programming. Because of a lot of answers in for these problems are found in the fundamentals of software engineering. And since functional programming is very close to the fundamentals, that is where I could find some problems, the solutions. It's important to know here that I didn't come to functional programming from an academic point of view. I came there because I had practical problems and I needed practical solutions. And if there's one thing I would like you all to really take away from this talk, is that you don't need a mathematical background to try functional programming. You just need a little bit of curiosity about what are the underlying problems. So today, we're going to talk a little bit about functional programming theory. We're going to talk about monads, everybody's favorite subject in functional programming. We're going to see how they can improve like a real-world application. And we're going to end up with talking a bit about optics and about smart types. So let's talk about functional programming theory. And a good place to start there is the question, what exactly is functional programming? Well, this is quite a difficult question to answer, since I think every person, every functional programmer will have a slightly different answer to this question. So I'll just give you my current answer. And what is functional programming? I think it's a story about love. I think it's about loving your compiler. Because within functional programming, we try to move as many exceptions from the runtime to compilation time. So this way, it becomes impossible for exceptions to happen at production, because the compiler will stop you from making mistakes. It's about loving your team members, and to a certain extent your future self, by being very explicit. And with that, I basically mean that code should do what it says it does. That sounds really obvious, but that isn't always the case, and we'll see an example of that a bit later. And it's about loving your cake, more on that later as well. And of course, about loving your functions, because after all, it's functional programming. So let's talk about functions. And most importantly, function signatures. So here we have a function foo that takes a string and produces an int. And this is also the function signature of this function. Given a string, produce an integer. And if we abstract it even more, given an a, produce a b. You might think now, yeah, that's basically every function ever. And that's true until the function can go wrong, until we need to do some error handling. So when an error occurs, we're now in an invalid state. We need to somehow short circuit, stop executing, until we either recover or the program just crashed. And the underlying problem here is that a function that can go wrong actually has two return values, a happy path and an unhappy path. So that's the underlying problem we're dealing with, because the language only supports one return type. So how does Kotlin solve this? It solves it using exceptions, its nullability system, and recently also the result type. You can see a bit of an asterisk in there. I won't be covering the result type, but I'll mention it a bit later again. So let's talk exceptions. Here we have the classical divide problem, where we try to divide two variables. And of course, if the second one is 0, things crash, because we still haven't figured out how to divide by 0. The function signature of this function is given two doubles, produce a double. The behavior of this function is given two doubles, I either produce a double or I crash your current thread, which is, in my opinion, quite extreme behavior. Because the only way for me to know that is because I took the time to write a bit of Javadoc on top of the function. And of course, all of you write Javadoc like this over all your functions. And of course, before you call any functions, you will actually read the Javadoc that's associated with it. But you might have some team members here and there that might not always do one of those two things. So it's actually quite dangerous. This function is lying to us. And the only thing that saves us is the documentation. Another alternative that's possible in Kotlin is its nullability system. Here we have a signature that given two doubles, produce a double, question mark. And in Kotlin, a question mark means that that variable can be null, which also means that both A and B cannot be null. The Kotlin compiler will prevent that from happening. So here we can just do if check, return null, or else return the correct result. In Java, this would be a bad solution. But because Kotlin has nullability built into this type system, this is actually a very good way to solve the problem. Because Kotlin will not allow you to do any operations on a nullable value without actually doing some checking. So because of that, we can do tricks like this, where we call a divide function, which might return a null. And if we can now use the question mark dot annotation, we basically say, if the variable is non-null, execute this function, and otherwise, just return null, do nothing. And that lets us chain through a happy path, only execute the function if the previous result was non-null, if the previous result was correct. And only at the very end, we can use the Elvis operator, that's the question marks, the hair and the eyes and such, to give a default value in case the previous statement returns null. So now, out of this divide, either comes the correct answer or 0.0. So those are two ways that Kotlin has. And if we look at the exception one, this is problematic because the function signature is lying to us. We don't know the behavior. But if it goes wrong, at least we know exactly why it went wrong, because we have this nice error message that's saying that we cannot divide by 0. If we look at the nullability system, now the signature, the function is now honest to us. It says it can fail because it can return null, but we don't actually know why it returns null. For example, in a database call, does it return null because there was a database exception, or does it return null because there were no records found? So we're missing the error context. So basically, I would like to have them both. I would like to have both an error context, and I want to have error as a return type. So I kind of want to have my cake and eat it too. And in my search to have that cake and eat it too, that's where I found the Arrow framework. So Arrow is a functional programming language library for Kotlin. It's still relatively new. Its 1.0 release was September last year. In it includes monads, some improvement to coroutines, some optics, and some metaprogramming. And recently, I also included the thing amazing support, because they're very active on the Slack channel. At some point, I actually posted a bit, this behaves a bit weird. I mean, it works, but the behavior is a bit weird. Like within 2 minutes, someone was like, oh yeah, that's a bug. And before I could type, oh yeah, no worries, I'll make an issue then, he already posted the issue link, and 2 hours later, I got a message, it's solved. So it is a very active, very helpful community. So that's Arrow. Now let's talk about monads. And we're going to talk about them from a more practical perspective. So we're going to leave all the mathematical stuff behind. That's just to prove that it works. Let's just talk about how can you use monads in your daily life. And a monad, for daily life purposes, you can just see it as a wrapper around a return value. Because your function, at that point in time at least, cannot return a value. For example, if an error has occurred, it cannot return a value. But also a future, for example, it cannot return a value now, so instead it returns a wrapper that can deal with the fact that it's not already there yet. So for all intensive purposes, monads are just wrappers around return values. So let's talk about the either monad. The either monad is something what we call an error monad, because it deals with errors, and we call it a right-based monad. And that's because it has 2 generics. It has a left generic, which contains the error context, and the right generic will contain the result we're actually interested in. To remember which is which, it's easy to remember right is right. If you're now thinking, that's actually quite a weird naming, yeah, it is, but it's the standard. Every language uses this, so we just have to get used to that. The implementation of the either is quite important, because it's implemented using a sealed class. A sealed class means that in this case, it has only 2 possible implementations, which is a left or a right. So you never get back an either. You always get back either an instance of left containing the error value, or an instance of right containing the correct value, but never both. So a function either returns a left or it returns a right. If we turn that into our divide problem, we can now see that our function signature is, given 2 doubles, I either return an instance of left containing a string, or I return an instance of right containing a double. And we can do our if check. In Kotlin, we don't need a new keyword, so we can just create an instance using either.left. And otherwise, we return an instance of either.right containing the correct answer. Of course, Kotlin, amazing language, lets us be even more lazier. So instead of this, we can use extension functions, which just add functionality to other objects, and just call .left or .right on it, which does exactly the same. We can even get more lazy than this and replace this whole thing with an either.catch, which basically does a try-catch around it. If it throws an exception, it returns a left containing that exception. We can also now see that the function signature has changed as well. Now a left contains a throwable. The more observable people of you might see that the asterisk is back. This is because Kotlin's result type basically does this. It's an either with on the left side a throwable, and on the right side the value you're interested in. So if this is all you need, I would suggest just using Kotlin's result type and don't use arrow. If we want to go back to a string as a left side, we can easily do that. We can just call .map_left. And the nice thing about this is, this function only gets executed if it's an instance of either.left. If it's an instance of either.right, this function will just get ignored. It won't do anything. And here we can transform the left into something else. For example, we can get our string back. If we can transform the left side, of course, we can also transform the right side. So turn our right value, for example, into a string. So now we know how to create eithers, how to get the value back out of an either. So we have a lot of code here. We're going to go over it one by one. So we can create our either. So my either will contain either an instance of left containing a string or an instance of right containing a double. One thing we could do is just call or null, which means if it's an instance of right, give me the correct value, otherwise give me null if it's an instance of left. We can also see that the return type is double question mark, since the value can be null. We can do a get or else, which means if it's an instance of right, give the correct answer, otherwise give back this default value. But if you're using these two things, you're not actually using the error context. And that's basically the whole reason why we introduce an either. So if you're only doing this, I would suggest using Kotlin's nullability system instead. If you want to do something with the error context, we can now pattern match over it. The when is basically Java's switch statement, and the is Java's instance of. So we can check if it's an instance of either.left, and now Kotlin does some more magic, because since you did an instance of check, it automatically casts my either to an instance of either.left. So if we try to get a value out of this, it will be a string. Same, if we do an instance of check of either.right, my either.value is now of type double, so we can do things like ×2 on it. Also notice we don't need a default statement here. And that's because my either was a sealed class. The compiler knows that these are the only two possible implementations, so it will actually, if you would leave out one of these, you would get a compilation error. And lastly, what we can do is do a get or handle, which is basically where we try to recover from being a left and turn it into a right. Well, in this particular case, I couldn't really turn a string into a double, so we just log an error and return 0.0. So because of the map operation, we can actually do the same thing as we did in Kotlin's nullability system. We can chain through a happy path. So we don't even have to think about errors until the very end. And it's so similar to Kotlin nullability. I just put them underneath each other. So we call a divide function. If that function went correctly, we call the next function. If that function went correctly, we call the next function. I'm using flat map here because we're calling divide, and divide returns an either. And basically, if the function returns an either, you should use flat map, otherwise you should use map. And only in the very end, we can decide, oh, what should we do if something went wrong in any of the previous operations? Well, let's just return 0.0 then. So if you can use Kotlin's nullability system, you can also use monads. It's that simple. So let's see how we can use eithers in a real-world application. And for this, I kind of made a pseudo Spring Boot-ish application, since I thought everybody would probably be most familiar with that, where we try to basically create a booking that books a speaker for a conference. So first we'll try to make it just using normal Kotlin, and then we'll see how eithers can improve this. So we'll create 3 repositories, one to get the speaker, one to get a conference, and one to store a booking, which is just a combination of speaker and conference. Very simple application. So our service will probably look something like this, where we get the speaker, we get the conference, we create a booking, and we store the booking. And our controller might look something like this, where we call the service to create a booking, and just return a HTTP 200. Can anyone see what might be wrong with this code? What about errors? What if the database connection failed? What if a speaker couldn't be found? What if a conference couldn't be found? We didn't deal with those yet. Well, one thing we could do is just make sure that our repositories throw a not found exception in case something couldn't be found, and just surround this with a try catch. And just see if a not found exception was raised, we'll return a 404, and otherwise we return an internal server error. And this will work, but I think we can improve this using eithers. So let's see how that would look. And we'll start with creating the left side of the either, so the error context. And for that, personally, I like to use a sealed class. So we can define all our domain exceptions within the sealed class. In this case, we have a not found and a more general something went wrong. Now we can refactor our repositories to make sure it will return an either. with either a bad state or the value we're actually interested in. And I'm going to skip the service for a bit, but go straight to what this will do to our controller. Again, a lot of code. We're going through it one by one. So first, we'll call the service, which will return an either, which is either an instance of left containing a bad state, or an instance of right containing the booking ID. Well, we can now pattern match over it, and if it's right, everything went okay. We can just return an HTTP 200. Otherwise, if it's a left, because we use a sealed class again, we can now pattern match over the domain exceptions. If it's a not found, let's return a 404, and otherwise, let's return a 500. And now you might think, yeah, this actually looks quite similar to the try-catch. And that's true, but this has some major advantages. Because with the try-catch, we actually had to remember to put a try-catch there. By using an either, the only way to get a value out of an either is to actually make a conscious decision on what needs to happen if it's empty. So we're now basically forced by the compiler to implement a try-catch. And this is what I meant all the way in the beginning of my talk. We're trying to move exceptions from runtime to compilation time. And this also removes cognitive load from me. I don't even have to think about, oh, should I try to catch an exception? No, the compiler just tells me to do that. Not only that, because we use a sealed class for the bad state, I'm now pattern matching over that. What if in the future I wanted to add a duplicate booking domain exception? In our try-catch, I would again have to remember to add that clause. Because I use a sealed class and I added another one, this one will no longer compile until I added the missing case. So again, my compiler is forcing me to make conscious decisions on what to do. And that's something I really like. It also has a downside, and that's what we'll see in the service. Because in order to create a booking, we don't need eithers, we need the values that are inside the eithers. So we basically get a speaker either, a conference either, and then we need to do some flat map magic before we can finally create a booking. In this case, I would say it's still okay-ish readability-wise, but this can get quite unreadable quite fast, which is a bit of a shame, because I love that compiler support I get from having eithers. But I kind of hate the fact that I need to do this, and I kind of want to write nice imperative code. So I kind of want to have my cake and eat it too. So could Arrow solve this for us? Of course it can. We have monad comprehensions. And monad comprehensions basically make working with monads easy. For that, all we have to do is add this either block. And then within that block, the moment we have an either there, we can now call a new method on it, .bind. What it basically does is, if it's an instance of right, it gets the value out of it and puts it into that variable. If it's an instance of left, it will short circuit and return that left out of this function immediately. So the moment we arrive at this line, we know for sure the previous line went correctly. And in the end, we can return it. We also now see that the function is now suspended. That's because this uses Kotlin's coroutine framework underneath to do the short circuiting. If you don't want to use coroutines, that's also possible. You can just use either.eager, and then it's just a normal function. So let's see what this will look like in our service. So now we return either.eager. We call the speaker repository, call.bind on it, and just get the speaker as a value. Then, if that went correctly, we will execute this line. We get the conference repository and get the conference, and call.bind. And only if those two things went correctly, we can now make the booking, and we can now store the booking. So thanks to monad comprehensions, the service basically pretty much looked the same as the previous. But now we get all this compile time safety that eithers give us. So what did we learn here? We can have compile time safety using eithers, and we can still do imperative programming like we're used to, thanks to the either comprehension. And that's why the last thing is my favorite feature from Arrow. So this was the bit I actually used in production, and that worked really well. I wrote the most beautiful piece of code so far using this mechanism, since I could only have to think in the happy path. I didn't use optics in production yet, but it's also a nice thing if you don't know what it is to realize what optics actually are, because it can be useful, quite useful sometimes. And it starts like if you have like immutability. If I don't have the time to go into the immutability pattern, we had to talk about that this morning. If you're still not convinced, please come to me after this talk. But Kotlin's data class supports the immutability pattern really well. So let's create some data classes. We'll create a person, which has a name and a city. We'll create a city, which has a name and a street which will just have a name. Yeah. So we can create a person, and if you want to change the person's name, Kotlin's data classes have a copy method where we can basically say, make an exact copy of this object and just change the name in the copy. So it's very easy to change a name in an immutable data structure like this. The problem, however, is what if I want to change the street's name in an immutable data structure? Because it's nested immutable objects. Then we kind of have to do person.copy, set the city property, do person.city.copy, set the street property, and do the person.city.street.copy, and we can finally set our new city name. And as you can see, this is quite cumbersome. And again, on one hand, I really love my immutability pattern, but on the other hand, I kind of want to have ease of mutation as well. So I kind of want to have my cake and eat it too. And this is where Arrow optics come into play. And it does this with lenses. And lenses are objects that are made to look at a specific property of another object and to get and modify that value. So we can create a lens that goes from the person object to its city property, where we define a getter and we define a setter for it. So if we have a city lens, we can now get the city using the lens, and we can modify the city using a lens. I must say, modify hasn't been chosen that well, because it doesn't modify the property, it will return an immutable copy of it. So modifying is actually copy and just change that variable. And this isn't very useful yet, since we could have just used a normal copy for this. The power starts coming if we add more lenses. So if we define a lens that goes from city to its street property, and then define a lens that goes from the street to its name property. Now we have 3 lenses, and we can start combining them by composing them. So now we have a lens that goes from person to its city property, to the street property, to the street name. So by combining those, we now created a more powerful lens that goes straight from person to the street name. And now we can use this lens to instantly create an immutable copy of person and only modify the street name property. So if you have deeply nested data structures, lenses are actually quite a powerful way to just change properties deep within the structure. If you're now thinking, yeah, that's nice and all, but all this lenses creation, that sounds a bit more work than just doing that one-time copy, you would be correct. So luckily, Arrow can just generate these for you. If you put an add optics in front of your data class and supply a companion object, the companion object is the place where Kotlin stores its static variables and its static methods. It will just put static variables of all the lenses of all the properties of that object there. So after doing this, we can just have to do person.city.street.name, and we can just modify that instantly, modify the street name, and we don't have to write all those lenses ourselves. Arrow just does this for you. So if you have a domain, immutable domain model, which is deeply nested, you might want to take a look at optics, because they can really save you a lot of copy work within Kotlin. It also has some support for if you have lists and such, it has a traversal. If you're dealing with sealed classes, it also has prisms, which help you with that. And it also has ISOs, which allows you to turn object into tuples and tuples back into objects. If that's stuff you need, I don't have time to go into that right now, but the object library also has that stuff. So what did we learn? Lenses look at a single attribute of an object. Alone, they don't do that much, but we can compose them to create more powerful lenses. And Arrow can just generate these for us, so we don't have to do that ourselves. And lastly, I want to talk about smart types. This is something I would personally say is not production ready yet. It still has some kinks here and there, but I wanted to show it off because it shows a lot of potential. So it's really cool, but wouldn't use it in production, at least yet. So let's take a look back at our divide problem. We try to solve it in 3 different ways now. We try to solve it using runtime exceptions. We try to solve it using Kotlin's knowability system. And in the end, we ended up solving it using its either. But there is actually another way to solve this problem. And in a way, that's my favorite way to do. We can prevent the problem from ever occurring. We can just write a bit of Javadoc saying that b should just be positive. And now nobody is allowed to call my function with a negative value anymore. It's that easy. Of course, we're back to the problem that people actually need to read Javadoc. So one thing we could do it to force that by compile time is just write a class positive, which in its constructor checks if the value is greater than 0, and just make sure that b is of type positive. And now it's impossible to call my divide function with a negative b, or with a 0b. Can anyone spot the problem here now? We're back to a runtime exception now, because the moment we create a positive instance of positive, and the constructor sees we try to put a negative value in there, we now get the compilation time, get the runtime error again. And this is where Arrow's analysis plugin comes in. Because if we add the error analysis grader plugin, and we now try to create a positive with a value -1, we now suddenly get the compilation error. The grader analysis plugin sees that we try to put a -1 in an object which requires a positive value, and it won't allow you to do that. Your code will no longer compile. So just by adding a grader plugin, my runtime exception suddenly got moved to compilation time. And this is, in my opinion, a very powerful thing. So the error analysis plugin allows us to add preconditions and postconditions to our code, to give information to the compiler about what it needs and what it produces. And then it has a nullability-like compilation time check, where you have to prove to the compiler that these preconditions have been met. It also has some laws to add things to third party, and unfortunately, it only works on Gradle right now. So let's take a look at these pre and post conditions. Instead of pre, you see I wrote require there. That's because this plugin outdates the require keyword. It used to just be pre and post, but at some point Kotlin added require, and they just decided to support them both, so you should choose require here. With require, we're saying that the input should be greater than 0. So we add information to the compiler that whatever comes in must be greater than 0. And with post, we add again information to the compiler that whatever comes out of here is guaranteed to be bigger than 1. So now the compiler knows these two things. And now, because the compiler knows these two things, if we try to call a function with 0, it will not compile, because it knows it should be greater than 0. You're putting in 0, that's not going to work. So the plugin won't allow you to compile your code. If you put in value, well, the compiler doesn't know what the value of that could be. So it won't allow us to compile the code until we prove to the compiler that value is actually greater than 0. And only then it will allow us to call foo with our value. The return type, my positive int, because we added a post condition, the compiler knows that value is guaranteed to be greater than 1. So we can now call a foo function again with that value, because we already proven to the compiler that whatever came out of my foo function will by definition be greater than 0. Personally, I don't like to add pre and post conditions to all my functions. So instead, I like to use objects. So I would create indeed a positive object, add a require there, and just make sure that the input of the function is a positive and the output is a positive. So this way, the compiler already has all the information it needs, that what comes in is greater than 0 and what comes out is greater than 0. It doesn't only work for integers. You can also make it work, for example, for strings. Like if you have a certain database constraint that a string should only be a maximum of 10 characters. So we can actually define a class that checks for that. And now the compiler won't allow us to create strings that are longer than 10 characters until we actually proven to the compiler that we're doing it okay. It also works on collections. So if you try to get the first element of a collection, what if the collection doesn't have a first element? What if it's an empty collection? So this could go wrong. So the error analysis plugin won't allow you to call first on an array before you check that the array actually contains elements. This doesn't only work for first, this also works on index. If you try to get the third element, you first have to prove to the compiler that the array actually has those, the right amount of elements. This is a bit weird that this actually works, since the previous times we declared the data types ourselves. And this is because Arrow has something called laws, where you can add pre and post conditions to existing libraries. And the Arrow team actually wrote laws for all the collections already for you, so you don't have to do that yourself. So here, for example, for the first method of a list, we add some preconditions that need to be met. So the good parts about Arrow Analysis plugin, it's great to add constraints to our domain model. Like, for example, if you have database field length, we need to consider. Some external services might have certain restrictions. Basically, this allows us to make illegal states unrepresentable at compile time, which is incredibly powerful. It also has some downsides. So right now, it's still somewhat limited. It only works on integers. It works on strings, but only with the length function. It doesn't support contains yet. They're still working on that. And it works on collections. Also, sometimes it works a bit too well. I try to write some code here and there, and suddenly in your unit test, I just want to call something, and Error Analysis plugin will be, nah, you didn't do a check. So you have to do, once you add this plugin, you have to do checks everywhere. You can opt out, but then you need to add plugin-specific code, and I personally don't like to do that. Another problem is it doesn't really work well with deserialization. So if you're using Jackson or Hibernate, this compiler can't check that because it all skips the full constructor, unless you write your custom mappers and such, but yeah, nobody's going to do that. So this basically means you can only use this for your domain entities. And lastly, unfortunately, it doesn't really support the Stream API that well. Since if you, for example, do a filter to check if the value is greater than 0, this checking happens in a different context than the actual mapping. And the compiler can't figure out that we already did the checking. So there's a workaround that's using map not null, also something I don't like yet. So there is some work to do on this plugin, but the potential of moving all my runtime errors into compilation time by just adding one plugin is really awesome. So I'm really looking forward to what they're doing with this project in the future. So what did we learn from that? We can move turn runtime exceptions into compile time exceptions. We can make illegal states irrepresentable. And because I needed a cake analogy, I would say this is the cherry on top. So what did we learn today? We learned that thanks to Arrow, we can have both an error context and error as a return type using iders. We can have both compiler support from the iders and still write imperative code using the idle comprehension. We can have both immutability and ease of change thanks to optics. And we can remove runtime exceptions to compilation time thanks to the error analysis plugin. So I think I could safely say that thanks to Arrow, we can have our cake and eat it too. If you have any questions about this subject, either come to me now, feel free to add me on Twitter or LinkedIn. I didn't lie when I said I was very passionate about this subject, so anyone I could help with this, I would love to do that. You can find the slides on that link. Thank you so much for your attention, and enjoy the rest of the conference.